Hello everyone, and welcome to a short presentation on inner source software development and how it relates to financial compliance and in particular transfer pricing. My name is Dirk Riele. I'm a professor of computer science at University of Erlangen, and this is a somewhat generified version of a presentation I gave at the Ministry of Finance in Germany. This talk is aimed at non-technical people trying to understand the impact of this new form of software development called inner source, again on financial compliance. I'm a professor of computer science. I teach at University of Erlangen. I worked in industry for a long time in Silicon Valley and Boston, and returned to Germany in 2009 for my current position. So inner source software development is the use of open source best practices inside a company. Legally speaking, no open source software is developed. It's still company-owned software. But the practices are very different from how you traditionally develop software. Traditionally, you have fairly strict hierarchical structures where people get assigned to projects. And inner source, using open source best practices, breaks open those silos and facilitates and makes possible collaboration across these silo boundaries, across organizational boundaries, across business unit boundaries. Empirically, the effects are known. You get better software quality, you get more easily reusable components, and employees share their knowledge much more efficiently than when they were still confined to their silos. In general, employees are more satisfied. What it means is really confusing from a traditional company perspective. If you're an engineering manager, you should be talking about your projects. If you're a software developer inside a company, you should be marketing the software you're working on. So you're not quiet. You have to show your work. You don't hide it behind firewalls or access protection. You show your work to other people. And when they come and are curious, you welcome them and you engage with them. Because the goal is for other people to use your software rather than to hide your software from them. The goal is to make them use your software and eventually get them to contribute to your software. This way you get higher quality of software because more eyes are looking, the more people are using, the more people are contributing, the higher the quality of the software in general. So then we have to distinguish between the actual artifact, the software being developed, now in inner source that is jointly developed software by people from very different parts of a company. And so they are not specific to a particular project or product. The software components that are inner source software components are widely shared, are widely used in different products, and hence they are an asset to the whole organization. To get there, people need to collaborate using inner source style collaboration, where the focus again is on that shared component. And regular software development collaboration becomes inner source collaboration by definition if it goes across any silo boundaries, if it goes across any traditionally or originally hard assigned jobs and responsibilities. The easiest way of illustrating inner source is if you watch how work flows between different people from different org units. So here you can see a set of fourth level org units. It's been anonymized, so AAAA, that's the org unit to the left. And the incoming arrows show work in the form of code contributions, program code being written from other organizational units. This is real data. We anonymized it. You may think that, say, the work that flows from AAAB to AAAA is, well, probably it's the same project, maybe. But if you look to the right, you see org unit BABA, from a different business unit, that's even a different company. And they are contributing work to a project or software managed by org unit AAAA. So that is inner source. You go across the silo boundary and contribute work. Spend your work time in the form of writing program code on somebody else's. That's the first take component, but then it becomes an inner source component done right, meaning it's a shared reusable asset for every party involved. I'll get to the challenges of that in a bit. From an economic perspective, in our research, the easiest way to view it is as workflows or patch flows, as we call them, code contribution flows, meaning work gets expressed in the form of written program code, intellectual property, that a person contributes to some software component. And if that software component is not one they have been originally assigned to, then it is an inner source software component. So here in this table simulated for some top secret software component, you see rows where each row represents a code contribution, a piece of work, some intellectual property created by a person. It's ordered by time. You can see it keeps going, spans days. But it's actually pretty frequent. So such code contributions, in technical terms, they are called commits. Such commits in real software development, they come into a code repository, the shared code base that people are working on, at a rapid pace. Not every hour as here, but really sometimes every minute or so, if it's a busy project. So it's small contributions by different people. So the second column here, the author, indicates anonymized the author of the program code, who wrote the code, who performed the work. And I'm illustrating here how they are from different business units. That's inner source. It may be legally speaking different legal entities, different business units. They still collaborate in inner source. That's the idea. You can uniquely identify the contribution. That's the commit ID as a technical ID. And then the work itself can be quantified. A very simple, not very exact way of quantifying the work that is being done is by the lines of program code that the developer wrote. So I use that as a proxy for work being done here, but we are working on much better measures, of course, because it's very rough and can also be very misleading. So for one inner source component, a way to look at it is that the inner source component consists of a stream of transactions that you can manage in an account of inflowing code contributions which represent intellectual property, which represent work, being provided from very different people in different legal entities from all across then usually a holding company. It doesn't have to go across legal entity boundaries, but of course that's where we are headed, because that's where inner source touches on our topic of transfer pricing here. And to make sure we are talking about the same thing and see the differences, there are 3 degrees of openness and therefore 3 types of program code that people write, if you will. On the right, you can see product-specific code that sometimes, if there's shared code between related products, is put into a platform. That is still traditional classic software development. And that code is not very open. It's specific to this set of products or that product line. As soon as you start collaborating on shared reusable assets that you want to reuse because of their quality, because of wanting to save costs, as soon as you go across multiple product lines, usually then even across multiple company boundaries inside a holding company, you'll get inner source. That's the middle pillar here. Inner source is intellectual property, program code, that is very valuable to the company. It is shared by very different, to the holding company. It's shared by very different products and projects, and it is not open source because it is competitively differentiating. Any company that knows what they're doing will keep private, proprietary, any code they consider competitively differentiating, and only if they see that this code doesn't make a difference in the marketplace will they open source it. So open source code is intellectual property code that is not competitively differentiating. So 3 stages, and we are talking about the middle stage, and in particular now about the situation where the work flows across the boundaries of legal entities. So from a compliance perspective, what's happening here? So people from different business units inside a holding company may contribute to each other's work. So IP flows across a legal boundary, which also usually means a tax boundary. So the tax authorities will take notice and wonder, how do we price that to avoid profit shifting or any other unwanted things? One way of looking at it is to view the contribution that one business unit makes to some other business unit software component as a service provision. So it's just like a consulting service, and then so it's asymmetric. There's one supplier and there's a client, and the supplier receives something from the client receives something from the supplier, and then they have to compensate them for it, and we have the established OECD methods for that, and that seems easy enough, maybe. First of all, you need to have that explicit contract, but maybe you can put that in place. An indicator that you actually have such a service provision situation as the correct economic model, underlying model, is really if all the economic risk is with the client and the service provider has no risk because they are not using the code. This is how we as a researcher, as a computer science researcher, get explained how to look at inner source from a tax perspective. And I have to say, maybe, but that's actually not what is usually happening, at least not what's actually happening in inner source specifically. Let me motivate before I come to how an engineer looks at it, and that may require different economic thinking. Before I get there, let me emphasize the significance of inner source for product vendors, and not just software vendors, product vendors, any product vendors like automotive, logistics, electricity, energy, what have you. So we all know that software is everywhere and that software is increasingly in every product. However, beyond it's just part of a product, it is actually becoming a key differentiator. So in automotive, one reason why people are excited about Tesla is because it just has this fabulous software that you do not have yet in other cars, in many other cars. So software is not just something somewhere deep in the bowels of a product. It is actually a key differentiator that makes a difference in sales. And as a consequence, getting the software right means you need to understand your market and the software needs. You think you are selling a car, but you're also selling software. So the software developers or the product managers for software development need to be close to the market, to the actual, how the product is being sold, how it's received by the market. Which is why it's a really bad idea what some companies are doing at present, which is to move software development into some separate business unit, which services then the product units. This really will have to be reversed in those cases where it happened, and the software has to move back close to the market, close to how and where the product is being made. Now, if it's been moved to some internal software organization, it's one step more removed from the market, and that's really bad if the software is making a difference as to a sale. Now, if in the future or already, software companies know that they should not remove software from from being close to the customer, but non-software vendors often do what I just described. As a consequence, when you move software back close to the customer, you break up that software house, that internal software organization, and so they are not in one place any longer. For them now to collaborate, they will need inner source, because the focus of the software people in a car is on, in mobility, is on that SUV or that scooter or that, I don't know, truck they are selling. So they are close to their markets, and to collaborate now, they have to collaborate across the different business units for these different products, and for that, they need inner source. Inner source is the future of large-scale software collaboration in these companies. So with that, how do engineers look at inner source? Well, it's not a provision of a service. Inner source from an engineer's perspective is a collaboration for mutual benefit, like an open source. There's a software component that I could use for my product. I use it. It has some bugs. I fix the bugs and I contribute the bug fix back to the software component. I use it for my benefit. I contribute for everyone's benefit. I contribute so that I maintain my stake in the software. I'm recognized. I will not change things without consulting or involving me. So different parties are peers. They are not client and supplier. They are peers in collaborating on one shared asset. And that is collaboration for mutual benefit. Now, on a more compliance level, technical level, so financial technical level or economic level, the intellectual property ownership may still be with one of the participants because the software needs a home, but then it will be provided under some defined inner source license to the other parts of the company, say within a holding structure. You need that home for managerial purposes, but the practice of it is it's a shared asset across the organization that is being developed collaboratively for mutual benefit. And that, of course, it makes it even harder to look at it from a financial compliance perspective. First of all, it's purely a managerial problem or challenge. How do we account for who does what work and how we operate our company? All right, that's a different topic. Now I want to focus on if people collaborate across tax boundaries set up by legal entities, different companies in a holding structure, how do we account for it from a tax perspective? And specifically then, what is a transfer pricing model that could work to account for the IP that's being moved forward and backward? So here are the well-known OECD methods in English and German, first and second column. We had a master thesis where one student looked at a specific situation with one company. He concluded that it was indeed a service provision of one company within the holding located in India, contributing to the product developed by another company inside the holding in Germany. All right. And the applicable transfer pricing method would be a cost plus. He concluded that other methods didn't really apply for practical purposes. If you wanted to look at profits, they were too far into the future, and simpler methods, other methods would not be applicable because you wouldn't really get a comparable price and so forth. So, as I said, I do not think that this is true inner source or how engineers would look at inner source. Again, inner source from an engineering perspective, from an engineer's perspective, is collaboration for mutual benefit, like in open source software development. So from that perspective, as everyone pays in and also takes out, and the net would have to be a profit or at least a break even, because otherwise why would they be paying in the form of work? Well, then, in my opinion, we are probably best served by looking at it as some profit creation. and hence the profit method, like profit split or net margin method, would be applicable. How to model that? I don't have an answer for you yet. We are working on it, but we are computer scientists, so we are in need of our collaborators from the ministry and from the consultancies. So I will make this talk available. You had lots of links at the bottom. This is me. Thank you very much for your time and attention. You can reach me as displayed here, and I very much would be interested in your questions now. Thank you very much.